Hello, welcome back. Here we go. So this is an equation. This is also an equation. What's the difference between these two equations? Well, one of them has nothing but letters, and that looks scary, and I really don't want to look at that for a moment. This one has numbers and letters. So what are we going to do? Well, let's do what comes naturally and let's try to simplify this. Okay? If it doesn't come naturally quite yet, practice. Practice in this instance is going to help a lot. So what I have here is I have 2 times x. And what I'd like to do is figure out what that value of x is. Right now it's currently unknown. So we're going to divide both of these sides by 2. Okay? So I'm going to divide by 2. And this ends up being 2 divided by 2, which is 1. And 1 times x is x. That's why x is by itself now. 6 divided by 2 is 3. So I now have 3 equals x. All right? So this is pretty straightforward. We've done this before. Right here. So how does this apply to this expression or equation right here? This is an actual equation that we use in science. It says distance equals rate times time. It is a common relationship that we use in some problems. So what happens if I'd like to get t by itself? All right. It looks just like an equation. 2 parts on this side, r times t, and 1 part on the left side, d. Well, if I want to get t by itself, we're going to use the same process we did over here when we were trying to get x by itself. In order to undo multiplication, we're going to divide. We're going to divide by the piece we do not want to have with t, in this case r. And then if I do it to one side of my equation, I have to do it to the other side, so d divided by r as well. And I'm left with d divided by r is equal to r divided by r is 1, and then t is left by itself. 1 times t is t. So what's the difference between what we did over here and what we did right here? What we did right here, the numbers allow you to be able to simplify because you know something about them. You know that 6 divided by 2 is 3. Over here, we don't have any specific details. All we have are letters that represent values that we do not have yet. So this enables me to use the distance and the rate to figure out what the time is. Whereas our previous form of this problem allowed me to figure out what the distance is using the rate and the time. Okay? So being able to manipulate equations comes in very handy depending on what information we know. That's why even though you're used to seeing this, you're doing the same thing here, but in a more applied way. Let's try another example with another equation you're going to become very familiar with. Okay? So let's try this right here. This equation right here is going to be this equation is going to be there. This is the equation of a line. Okay, it's in it is a linear equation. It's in what we would call slope-intercept form, but we only have one variable. This is the actual linear model. Okay. It's not quite how you would remember it, but we're going to show you how to manipulate that in a moment. So here, we're going to isolate the variable x. Okay? So how would we do this? Well, it's not bad. Just subtract 3 first, just like you would in any multi-step equation. You're left with 2x by itself. 3 minus 3 is 0. And then 7 minus 3 is 4. Okay? Right here, we're going to have 2x, so 2 times x. We're going to divide both sides by 2. That leaves us with x. X times 1, which is x, and 4 divided by 2, which is 2. Okay? So it's not bad, right? It simplifies nice, and we have one number as our answer. Well, over here, we have nothing but letters. So let's say we want to isolate the y. Well, what are we going to do? Well, take this whole piece right here, and let's subtract mx from both sides of my expression, or equation. I have y equals, because mx minus mx is 0, b minus mx. Okay, so I've isolated the y value. Okay, it's essentially the same thing. Now, what if I wanted to isolate the x value? It's the same as what I did over here. I would subtract the y. Well, let's do it. I'm going to erase this. Oh no, I can just write next to it. Here we go. So we would subtract the y, and you'd use mx, y minus y is 0 equals b minus y, and then we would divide both sides by m. And you'd get here, m divided by m is 1, which is 1 times x is x, and b minus y divided by m. And it doesn't get any simpler than that. Unfortunately, it doesn't look simple. Sorry about the bell. Doesn't look simple, but in each case, we've simplified it as best we can and isolated the variable that we were looking for. I'm going to show you some more examples, and I'll do it on paper. All right.